Hello, everyone. My name is Appeltans. I'm the project manager of OBIS, the Ocean Biodiversity Information System. And in the next 15 minutes or so, I'll give you an introduction to OBIS. To start with, OBIS is a project of IODE. IODE is the International Oceanographic Data and Information Exchange Program. It's the oldest program of IOC, of the Intergovernmental Oceanographic Commission of UNESCO. And every project in IOD has a steering group. So the steering group defines the work plan and the budget, and also establishes task teams to implement the work plan. The work plan is then submitted to the IOC Committee on IOD, which are the 80 national coordinators in data and information management. And they approve our work plan and budget, and then they submit it for adoption at the IOC Assembly, where we have the 150 member states. The IOC member states in 2019 recognized OBIS as the global open access data information clearinghouse on ocean biodiversity. That's because at the moment we are the most comprehensive database on the distribution, the diversity, and the abundance of marine species. We have more than 60 million occurrence records of more than 135,000 marine species. We integrate data from more than 3,000 data sets, and we have more than 55 million measurements or facts and facts. That has not always been the case. More than 20 years ago, Les Watling and Sarah Gerken, for example, they produced this global biogeographic map, but they could only focus on the coastal areas because the knowledge of the deep sea and the open ocean was so little, it was impossible to draw conclusions on biogeographic regions. A lot of that changed during the Census of Marine Life, the 10-year program to document what lives and will live in the ocean. And OBIS was established under that program. It was adopted by IOC in 2009 because the Census of Marine Life was only for 10 years. I always want to stress that OBIS is more than just a data system. It's a whole network of people, of scientists and data managers. We have about 30 OBIS nodes, and about 50 people are working on a daily basis to make OBIS what it is today. So it's not only about data, it's also about developing tools for data access, data processing, quality control, doing analysis. There's a lot of training involved. We have to train our OBIS nodes, we have to train our users on how to use data from OBIS, and a lot of data standardization. About training, so far we've organized 23 training courses. We've trained more than 300 people from 71 countries, and we do this together with the Ocean Teacher Global Academy. The Ocean Teacher Global Academy is also a project of IODE, and they have established a number of regional and specialized training centers. They will have soon 16 training centers all over the world, training in different in their own local languages, local use cases, etc. It's a really successful program. So if you go to the OBIS website, under activities and training, you can see the alumni list of people that are trained by country. And if you go through to the Ocean Teacher Global Academy website, you can find all the training courses. You can see all the training material is still available online. So anyone is actually able to do the training by themselves online, if not face-to-face. One slide on the data flow. I think this is very comparable to the deep data system. So the data providers provide their data in Excel or whatever format to the OBIS nodes. These can be national or regional or thematic OBIS nodes. They do all the standardization and quality control, provide the QC reports back to the data providers. So because it's important that the quality is up to date at the source level. Because they send a new version, so that the same errors are not repeated in the next version. Then the OBIS nodes publish it on a server, which is called the IPT, the Integrated Publishing Toolkit. And from there, we can harvest it, index everything, quality control everything again, send a QC report back to the OBIS nodes. We also collaborate closely with GBIF, the Global Biodiversity Information Facility. They also harvest the OBIS node IPTs. We make everything available through our API web service, where we, which is also powering the R package in OBIS and the portal and the mapper. Let me give you a quick demo of our portal and what a QC report looks like. For example, you can search by data set. Let me see. Let's go for deep sea Mayo Bentos data set. So this is a data set page where you get the web link to the original data set, an abstract, a citation. If somebody wants to use a data set, they know how to cite it. The Creative Commons license, some keywords and some contact information. Here are some bit of statistics, number of records that are identified at the species level, the time range, etc. You can get a map. If you click here, you go to the mapper, some time, some composition, links to the data providing institutions, some of the top taxa, see if there are any red list species on this data set. No, there aren't. So go back to the data quality report. You can see there are no records dropped. There's some have some taxonomic issues. Some fields are missing, and there are a few records are reported as being on land or exceeded bathymetry. No accepted name. If you click on here, you can see there are a few species, so many records that have species that are indicated by the World Register of Marine Species as being not accepted. If you click on one of these species, you can see the species, the status is an adequate description. So that's the kind of quality flags that we add to every record in OBIS. If you want to get an overview of all the quality issues, for example, there are a number of records that exceed the bathymetry. Let's have a look. So these are all the records. If you want to view the records on a map, let's go to the point. Let's go deeper. So here are a number of records. Yeah, this one is clearly on land, and this one exceeds the bathymetry also. So if you want to have a look, 300 meters depth. So I'm not sure if this is true or not, but apparently, according to the JEPCO bathymetry, and in this case for Europe, we use the IMONET bathymetry. This exceeds the bathymetry according to those reference databases. You can download the data in a CSV file, but maybe let me show you another way to access the data. So you can search for data sets, search for OBIS nodes, institutions, fixed areas. For example, Bahamas. You can go to the EEZ of the Bahamas, for example. If you want to see all the records published by your country, time range, depth range, etc. You can also draw a polygon. Let me see. Let's have a look here at this area. Go to set. So we have more than 250,000 records from that area, but I'm only interested in the deep sea records. So let's move the slider up to everything below, let's say 1,000 meters. Okay, nothing there below 1,000 meters. Everything below 500 meters. Okay. Yes, there you go. So we have 10%, I believe, 25,000 records are below 500 meters. You can also have time range. So I'm only interested in the more recent records. 11,000 records. Click on save, and you can then download. You will get an email notification when the file is ready, or you just wait a little bit and the file is preparing. If you already want to have a preview of the data, you can see here a summary of how many species, how many records, etc. Some occurrences, the checklists, and the data sets. Back. Oops. So the download is finished. Download the zip file where you get a CSV file, but also an HTML file with all the dataset citations. An important new development in OBIS is moving beyond just species occurrences, because biologists are sampling more or observing more than just species occurrences. They do biometric measurements, sediment samples, nutrient concentrations, habitat cover, etc. Also more and more information coming from sensors, images, tracking data, etc. So, and we had to support the essential ocean variables, which are identified by the Global Ocean Observing System and collaboration with the Marine Biodiversity Observation Network of GeoBon. Also within GOES, you have the Deep Ocean Observing Strategy, or DOOS, which is the deep sea component. And there they are developing this data workflow to process, to get to the EOV, to get to the essential ocean variable products. You can see it's a very complex diagram because it's so much different types of information that is required to develop these products and these models. A lot of national institutions and projects and initiatives are involved, but I'd also like to stress that also DOOS is looking into OBIS to integrate all the biological data. And so when combined with the physical chemical data, you can produce these models and forecast products. So we had to agree on a data structure to accommodate these additional attributes, but we want to stick to Darwin Core's data standards. So we are very much promoting to use the event core in combination with the occurrence extension for the occurrence details and the extended measurement effect extension for all these sampling facts, the measurements, abiotic measurements and biotic measurements, as well as sampling protocols, sampling effort, and all the time information, the location information can go into the event core. We also added an ID types, the ID terms, sorry, to the extended measurement effect extension. For every measurement type, value, and unit, there's also a corresponding ID, which links to a controlled vocabulary. In this case, we promote the NERC vocabulary developed by the British Oceanographic Data Centre. It's very important because when you combine thousands of data sets, and when you point to this controlled vocabulary to have agreed definitions of the terms, data sets become interoperable, and you can easily combine them and make sure that you don't compare apples and pears. So the next step to support these essential ocean variables is we have to agree on data formats. So how do we implement this with the event core, occurrence extension, and the extended measurement effect extension? So we are developing these examples. In this case, we had a workshop on microalgae, and again, this is very specific type of data because this is habitat data that you cannot always resolve to a taxonomic name. So also that is possible now in OBIS. You can just have by using the measurement extension, just link to an habitat vocabulary, and the measurement can then be a cover of a particular habitat or percentage cover or surface area of a particular habitat. So all the measurements are not yet available through the mapper in the portal, but they are available through our web service and our R package. If you go to our YouTube channel, there is a presentation made by our data manager, Peter Provost, who shows you how you can use the R package, develop these graphics and maps, and even build web applications on top of OBIS. This is another example of where we produce biodiversity initiatives and maps to support a number of international processes, such as the identification of ecologically or biologically significant areas of the Convention on Biological Diversity. Again, everything is available through our GitHub. So all the R code, the scripts are available, so you can rebuild those maps. Another nice example is the use of OBIS in the World Ocean Assessment. Now we have the second World Ocean Assessment, which is still in draft. The second draft is published recently by Dualis. You can see OBIS used many times there. It's also in a number of deep sea chapters. Then in terms of collaboration between OBIS and the International Seabed Authority, in 2000, we signed an MOU, a Memorandum of Understanding, between IOC and NISA, which specifically mentions collaboration for collecting environmental data and information, but also exchanging data and information. Of course, in respect to the data policies in the different organizations. Also, the ISA published this action plan to support the UN Decade of Ocean Science for Sustainable Development. If you look at the action plan, also the ISA mentions a partnership between deep data and OBIS as one of the activities. And we hope, we are in the discussions on making this happen, to exchange the data from OBIS and the deep data systems. The action plan also mentions collaboration in terms of training. We look forward in organizing training courses together, in contributing data to different systems, using data for doing analysis, product development, application development. So this was in a nutshell what OBIS is. I can tell a lot more, of course. But if you have questions, please don't hesitate to contact me or Peter Provost for more technical questions. Thank you.